Okay, good morning. Am I audible? Hello. Am I audible?
Yes, sir.
Okay, in the last class, the screen share was not shared properly, I hope, correct? Hello. So in the last class, the screen share was not shared properly, isn't it?
Yes, sir.
Okay, today, anyway, can you see the screen share?
Yes, sir.
Hello. Sir, 6th B ನಂದೇ ಅಲ್ವಾ ಈಗ ನಮ್ಗೆ 9:20 ನಂದೇ ಶೇರಿಂಗ್ ಇಲ್ಲ ಶೇರಿಂಗ್ ಮಾಡಲ್ಲ ನಾನು ನನಗೆ ಆನಂದ ಕಳ್ಸ ಯಾರು ಅವ್ರದ್ದು ಬೇರೆ ಬಟ್ ನಮ್ದು ಎ ಸೆಕ್ಷನ್ ಮಾತ್ರ ಇದು ಬಿ ಸೆಕ್ಷನ್ ಮಾತ್ರ ಓಕೆ ತಗೊಳ್ತಾ ಇದ್ದೀನಿ ಅದಕ್ಕೆ ನಾನು ಓಕೆ ಮಧ್ಯದಲ್ಲ ಸಾಗರ್ ಫೋನ್ ಶೇರ್ okay so I hope you can see the screen share. So now we have discussed the types of precipitation and forms of precipitation. Now we need to measure the depth of rainfall that has taken in a particular area. So the depth of rainfall in a particular area. So the measurement of rainfall will be generally done by an equipment called as rain gauges. So now these rain gauges by which we can measure the amount of rainfall that has taken in a particular place, and also it gives you the information about the depth of rainfall as well as the duration of the rainfall and also the intensity of rainfall and also the areal extent of the rainfall. So these rain gauges are in order to estimate the depth of rainfall and the intensity of rainfall and the duration and areal extent of rainfall. Now, there are certain Indian standards to be followed or to be considered when you want to erect a rain gauge in a particular place. So, Indian standards have given the following precautions. What are the precautions to be taken when you want to erect a rain gauge in a particular area, so that you can get all the information regarding the rainfall in that particular area. So now, the amount of rainfall collected by a rain gauge, it mainly depends on its exposure condition, and therefore great care must be taken for selecting suitable site for a rain gauge. So here, the main thing is whatever the amount of rain gauge that is in a particular area, so the surrounding these rain gauges, there should not be any disturbance like high-rise building or any commercial activity or any other construction activity around this rain gauge, because it will affect the catch of the rain gauge. So the amount of rainfall collected by a rain gauge mainly depends on its exposure, that is the surrounding condition surrounding the rain gauge, and hence great care must be taken for selecting a suitable site for the rain gauge. So this becomes the reconnaissance part. So you have to, in surveying, you know what is the reconnaissance. So first you have to select a particular place, and then considering all the factors, that is the surrounding condition, then we can select a suitable place for erecting a rain gauge. So according to Indian standards, the following precautions must be taken while selecting a particular site for a rain gauge station. So first one is the site should be on a level ground. Preferably it should be on a level ground, and that is the sloping ground and hilltops or hill slopes are not suitable for erecting a rain gauge. So the site should be an open space. That means surrounding that rain gauge station, there should not be any activity, human interference or human activity or construction of high-rise buildings or so. So the best place is an airport where there is least disturbance of human interference. So the best place is an airport, so where you have this level ground, so that there is no human interference, so that whatever the data you get in that particular rain gauge, the accuracy will be about 80 to 85%. So now, next is the third point is the horizontal distance between the rain gauge and the nearest object should be twice the height of the object. So you have to maintain a particular distance from the rain gauge. So any particular permanent object you have, that means the horizontal distance between the rain gauge and the nearest object should be twice the height of the object. So next is the site should be away from continuous wind forces, because if we have a high blowing wind, so it may distort the catch of the rain gauge. So it may distort the catch of the rain gauge. So preferably the area where you select a site for rain gauge, so the wind forces must be minimal. You cannot avoid, but the wind force, especially in open area, the wind forces will be very common. So it is preferable to select an area where you have the least wind flow forces effect. Next, the site should be easily accessible. So that since all these rain gauges, we have two types of rain gauges. One is the non-recording type of rain gauge. The second one is the self-recording type of rain gauge. So the non-recording type of rain gauge, so generally used throughout the world, is the Siemens rain gauge, whereas you have the self-recording rain gauge. That is, it is automated. It is automated. So here, in case of the non-recording type of rain gauges, one has to go and collect the rainfall data on regular daily basis. So whereas in the self-recording type of rain gauge, so since it is mechanized, so there is no human intervention, or no one can. You get the rainfall data on a graph sheet, so it is self-automated. So next is the horizontal distance between the rain gauge and the nearest object should be twice the height of the object. Next, the site should be away from continuous wind forces, and the site should be easily accessible, and the gate should be erected truly vertical, and the observer must visit the site regularly to ensure its proper readiness for measurement. So now, generally, in some areas where you have the sloping ground or hilltops, or a rain gauge has to be erected on a hilltop or a hill slope or a sloping ground. In such cases, the Siemens non-recording type of rain gauges will not work. So then we have to go in for the self-recording type of rain gauge. So the IS standards specifies that 10% of the total number of rain gauge stations of any basin should be self-recording. So we have three types of self-recording type of rain gauges. That is, one is the tipping bucket type, the second one is weighing type, and the third one is float type. So the non-recording type of rain gauges is the Siemens rain gauge. Now, this is the rain gauge. So you can see here the rain gauge has been erected truly vertical on a masonry platform, and surrounding this rain gauge, you can see a barbed wire fencing, so that there won't be any animal entering into the inside the rain gauge area. And also the surrounding area, you can see that. So this is the height of the object. So the horizontal distance from the object to the rain gauge station should be twice the height of the object. So these are the IS standards, and this is a non-recording type of rain gauge, and it is called as a Siemens rain gauge. Here you have a metal casing. Inside that metal casing, 1 minute. Inside that metal casing, you have a glass bottle, and you can see here you have a funnel type, so which acts as a receiver, So here you can see the setup. So this is a metal casing. So inside this metal casing, you have a glass bottle. So this glass bottle works as a receiver, and above the glass bottle you have a funnel. So which receives the rainfall. Correct? Which receives the rainfall. So it is in circular in diameter. Now you can see the rain gauge has been erected. You can see here, and around the rain gauge there is a barbed wire fencing, and since it is an open area, it's a level ground. So here you can see on the back you have the mountain ranges, so that the wind forces will be minimum. And here we have an anemometer, which gives you the direction of the wind. direction of the wind. So now let us discuss the types of rain gauges. So as I said, the first one is non-recording type of rain gauge, that is Simon's rain gauge. The second one is the recording type of rain gauge, that is tipping bucket type. And the second one is weighing bucket type, and third one is the float type with siphon alignment. So now let us discuss one by one. Now, this is the figure which gives the dimensions of ಯಾರ್ರೀ ಅದು ಮಾತಾಡೋದು ಮ್ಯೂಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. Lock button. So now you can see the picture of the Simon's rain gauge. Now here you can see this is the masonry platform by 60 by 60 centimeter. So the rain gauge is erected over the masonry platform, and you can see here it is have a metal casing. It is circular in shape, and inside this metal casing you have a glass bottle. So the diameter of which is 7.5 centimeter, because the diameter of the metal casing is about 10 centimeter. So you have a space on either side, so that the glass bottle can be easily inserted inside the casing. And here you have a funnel, so which acts as a receiver. So this is the top of the rain gauge. It is in a circular shape, that is 30 centimeter above ground level. So this is the rim of the metal casing. So it is open to the atmosphere, and this diameter of this rim is about 12.5 centimeter, and the top level of the rim is about 30 centimeter above the ground level. So this is a very simple equipment. So whenever a rainfall takes place, so daily the rainfall are recorded, one in the morning, that is at 8:30 Indian Standard Time, and one in the evening, that is 5:30 Indian Standard Time. So one has to record the rainfall data every day. That is one in morning and one in the evening, and you have a measuring jar. So whatever the amount of rainfall that is collected here, so it can be measured by this measuring jar, and the data have to be entered on daily basis. So this is the figure shows the non-recording type of rain gauge, that is the Simon's rain gauge. So next we have the self-recording type of rain gauge. So in which we have the tipping bucket type, and the second one is weighing type, and the third one is the float type rain gauge. Now you can see here this is the float type rain gauge. Here it is also a metal casing. Vinay Shankar. So now this is the figure of the float type rain gauge. Here all the dimensions have been given. Here you have a top circular ring of diameter 203 centimeter, and the height is 750 centimeter above the ground level. And here you have a casing, that is the base, and you can see here this is the funnel which receives the rainfall. Now here you have a float arrangement. Now here you have a filter. So whatever the dirt which is present in the rainfall can be removed at this point only. So a filter is provided, and this is the funnel which receives the rainfall. Now whenever the rainfall takes place, the funnel fills up, and here the water starts moving downwards, and here you have a float chamber. So the water enters the float chamber. Now this is the float, whatever the float that you have. So whenever this float chamber fills up, the float moves up. This float moves up, and here this float is attached to a pen or a marker. You can see here this float is attached to a pen or a marker, and here you have a revolving drum, that is clock driven drum. So you can hear you have a circular clock driven drum, and it is surrounded, so it's a circular, and a graph sheet is wrapped around this clock driven drum. So this is the clock mechanism. So it takes 24 hours to complete one revolution, and it requires rewinding once in a week. So it is a self-recording type of wind gauge. Now here you have a chart which is wrapped around this drum, and it is a clock-driven drum, and it takes 24 hours to complete one rotation, and it requires rewinding once in a week. Now, whenever water enters here and it gets filtered and it enters the float chamber, so which makes the float to move on. So here at the top, a pen or a pencil is attached here, so it marks the whatever the rainfall that has taken place in particular time. So you can see the graph here. So by this graph, we can calculate the depth of rainfall during any interval of the day, and also we can calculate the intensity of rainfall. So here, in case of self-recording type of rain gauge, you have a dual advantage. You can calculate the depth of rainfall as well as the intensity of rainfall in any particular interval of the day. So here, so once this float chamber fills up, so here excess water comes out through this siphon tube. You can have, see here, siphon tube. So whenever this is filled, so the excess water siphons out. So it is a self-reporting type of rain gauge. Here, once in a week, you can take out this graph sheet, and from the graph sheet, you can calculate the depth and intensity of rainfall that has taken place in a particular area. So now, generally, these are the following departments which maintain the rainfall record in our country. So first one is the Indian Meteorological Department, and second one is the Agriculture Department, and third one is the Forest Department, and the fourth one is the Revenue Department, and also the Public Works Department. These are the departments which maintain the rainfall record, that is the depth of rainfall and also the intensity of rainfall to our country. Now, next is these are some of the standards which you need to follow to decide how many rain gauges are required in a particular area. So it's called as the rain gauge density. So for plain area, one rain gauge that is of non-recording type for every 520 kilometers square. So for hilly area, one rain gauge, preferably the self-recording type of rain gauge for every 390 kilometers to 260 to 390 kilometers square. So for mountain area, one rain gauge for every 100 kilometers square. It is a self-recording type of rain gauge. Now, so we know the departments which maintain the rainfall record. So the rainfall records are generally considered for a period of nearly 30 to 45 years, 30 to 50 years. So if it is an island, so then you require a rainfall record of nearly 30 years. And if it is shore, you require the rainfall record for 40 years. And if it is a plain area, it is about 45 years. And if it is a hilly or mountain area, so it may require, you will require about 50 years of rainfall data. So for rainfall analysis in a particular area, whether it may be island, shore, plain area, hilly, mountain area, so you need these number of years of record for a frequency analysis of rainfall in that particular area. Now, so let us discuss the average annual rainfall. It is also called as AAR. It is abbreviated as average annual rainfall is abbreviated as AAR. So what is this average annual rainfall? So it is nothing but the mean of yearly rainfall. So it is nothing but the mean, that is the average of yearly rainfall observed for a period of nearly 30 to 45 consecutive years. So if you know the mean of yearly rainfall for a period of about 30 to 40 consecutive years, then it is called as the average annual rainfall. So the average annual rainfall. So if it is less than 45 centimeter, less than 45 centimeter, such areas are called as the arid regions. So especially the northwestern part of India. So these are the desert areas where the average annual rainfall is less than 45 centimeter. And the semi-arid regions, wherein you have the average annual rainfall between the 45 to 75 centimeter. So the peninsular India, so it belongs to the semi-arid region. So next is peninsular part, also the central part of India. It falls under the semi-arid region. And the humid region, the coastal areas wherein the average annual rainfall is greater than 75 centimeters, 75 centimeters. So such areas are called as the humid region. So as depending on the average annual rainfall, the areas can be classified into arid region, semi-arid region, and humid region. And the average annual rainfall is nothing but the mean yearly rainfall observed for a period of 30 to 40 consecutive years. So these are the uh, figures. So that is less than 45, it is arid. So between 45 to 75, it is semi-arid. And the humid region wherein you have the average annual rainfall above 75 centimeters. So next, index of wetness. So these are the definitions. So the ratio of rainfall in a particular year, in a particular area by the average annual rainfall. So we give you the index of wetness. So it's a number. So more the index of wetness means more rainfall has taken place in that particular area. So index of wetness is basically the ratio of rainfall in a particular year, in a particular area by the average annual rainfall that particular area. Because annual rainfall is always based on the mean yearly rainfall for 30 to 40 consecutive years. So by which you can know whether the rainfall is less or the rainfall is moderate, the rainfall is high. Now, so especially in hydrological analysis, so we require a lot of data because hydrological analysis is a very complex problem. So wherein the statistics plays a very important role. So whenever you want to carry out any hydrological investigation in a particular catchment area, we require so many data. So these are the precipitation data. So when we want to collect data, so there might be some errors in the observation or recording the particular data in a particular place. So the precipitation data errors are normally the most significant cause of the error in rain data is the observations are usually turbulent air flow around the rain. So wherever you have the lack of observation or lack of recording of the rainfall data, and also wherever you have the turbulent airflow around the rain gauge, so which may affect the catch of the rain gauge. So hence, whatever the data that you collect, it has some error due to the observation and wind flow. Next is the dependence of rain gauge catch on wind speed. So as I said, if you have a high blowing wind, so the catch of the rain gauge gets affected. So this is also one of the error in the rainfall data. Next, since the rain gauges are open to the atmosphere, so whatever the water that is collected may evaporate from the within the cylinder. So due to the evaporation losses also have crops of the error. Next, addition of water to funnel, whatever then water evaporates because sometimes what will happen, whatever the rainfall that takes place, sometimes some rainfall is attached to the funnel itself, so it in turn evaporates into the atmosphere. Next is any problem that is the functioning of the rain gauge, like the gauge leakages or blockages or overflow in storms. So or else the rain gauge has been broken due to some reason. So it may also be one of the factors for the precipitation data. So next is error in observation and transcription. This observing and recording also plays a very important role. The person who records the rainfall data, that is manually, should be honest in their observation and also recording the same one. So next is if there is heavy rainfall, there might be splash That is whatever the rainfall that falls in the funnel, it may be splashed outside due to the high intensity of rainfall. So these are some of the errors of the precipitation data. Next is estimation of missing data and adjustment of rainfall record. So now we know what is a rain gauge and what are the types of rain gauges and what is rain gauge density and what is average annual rainfall. And now, so sometimes what happens in a particular area, a rain gauge has been erected and it is operating, it is working properly. So in a particular area in a particular year, what happens due to some technical reason or due to any other reason, the rain gauge, the particular rain gauge may not be operative, due to technical reason or for other reasons. So in such a case, we have to estimate the missing data, whatever the missing data at that particular rain gauge station, and it has to be adjusted. It has to be adjusted for the current situation or the current present condition. So now, estimation of missing data and adjustment of rainfall records. So now, complete measured precipitation data are important to many problems in hydrologic analysis and design, but there are missing values. Now, the cause of missing of rainfall data are the failure of the observer to make the necessary visit to the gauge may result in missing data. Vandalism of recording gauge is another problem that result in incomplete data record or any technical problem, any functional problem of the rain gauge. Next, instrument failure because of mechanical or electrical malfunctioning can result in missing data. There might be many reasons, So we need to estimate. So estimate is nothing but it's a probable method. It is not the exact method. So we can, to somehow we can estimate the missing data at that particular station by using the following methods. So the cause of the missing data may be anything. So it may be due to failure of the observer to record the data, or it may be non-functioning of the rain gauge, or it may be due to any other reason. So now these are some of the methods by which we can estimate the missing data at a particular rain gauge station. Now, some of the methods of estimating missing rainfall values are, the first one is the station year method, the second one is the normal ratio method, the third one is the weighted average method, and the fourth one is the double mass analysis. So these are the methods by which we can estimate and also adjust the missing data at a particular rain gauge station. So I think the time is running out. I request all of you to mark your attendance in the chat box. So I will be ending the session.